the start. So before we do that, I'm going to do some intros. As I said, my name is Lawrence. I work as a product engineer at Incident.io, which makes me one of your hosts for tonight. So firstly, thanks everyone for coming. I'm really glad to see you here. Secondly, if you need an incident response product, nothing needs to be said. Cool, so I've been at Incident for the last year and a half, so I've kind of been spending my time building out a lot of the product that we have today and also kind of trying to shepherd our infrastructure along the way, because I think I'm probably one of the people with more infrastructure experience in my background. So obviously we just heard from Greg. I worked with Greg for several years before I came to Incident. So I used to be a principal SRE at GoCardless, where my job was kind of being the infrastructural engineer counterpart to Greg. So if he was concerned primarily about security and then about how we were doing it, I was concerned about how we were doing it and leaning on him for making sure that we were doing it securely. And honestly, I did have an intro that was kind of planned out for this, but having just seen Greg's talk, and by the way, amazing commitment to the fish analogy. Honestly, that was incredible. I think it's best to kind of look at this as my talk today is about taking all of that experience I had from GoCardless, growing the infrastructure there, and trying to figure out how to do things properly. And then turning up at Incident and trying to figure out what we could take from that experience and apply very quickly, so that when I first turned up, we could get something off the ground and try and, I don't know, turn it into something that would scale to where we're at today and hopefully further. So yeah, we're going to go through kind of the story of me turning up at Incident and look at what we cared about when we were setting up our infrastructure and what we ended up getting to, which I hope is a fairly decent end goal. And if it isn't, you can tell me afterwards and I'll be taking notes. Cool. So I think starting from scratch is kind of the name of the game here. So I was the first hire at Incident, so I turned up and we had 3 founders and they had been building some apps. What existed was like pretty simple and it worked. So both of those things are good. I think we can all sit here and say that complexity is not the name of the game here. But obviously we were just 3 founders and me, and I think nowadays we're about 55 people or thereabouts a year and a half later. So what I was focused on was, if I turn up right now, like, where do we go from here? What foundations can I put in place to try and create an infrastructure that we could grow into and feel comfortable in and be productive in actually from the get-go? Also, I think I gave myself about 3 days to do it, so it was fairly quick or scrappy. So yeah, before we go into kind of what I did, I think it's worth clarifying what I mean by right. So I think having gone through all the experience at GoCardless, I have a couple of opinions on what right would mean for us at Incident. So as a small company, when I first stand up, I think it's worth bearing in mind the context, because depending on that context, you might have different answers to this question. So the first thing is I want things to be simple. We're a startup, we have very few people, we're hiring a ton of them, and quite frankly, on the top of your to-do list of a startup like ours is never, I want to write hundreds of pages of documentation. So we obviously need something that people can set up and get started with pretty quick, and when things go wrong, they can debug fairly easily. The next thing is consistency. So this one is actually really important to me, and it might sound like another version of simplicity, but sometimes they can be in conflict. So for me, when it comes to infrastructure engineering, I think consistency means if I have a way to do something, say deploy a front-end application, whenever us as a company try to deploy a front-end application, we do it in the same way each time. And there's a ton of reasons why you might want that, but I'm going to kind of go into later. But just to contrast simplicity with consistency, if you have an abstraction to deploy a front-end app, you might choose to kind of compromise on some simplicity and add some complexity if you cared a bit more about making sure that all of your front-end apps were supported by that golden path, so they can sometimes be in conflict. And then the final one is we are an incident company. Remember that. And that means that we store all of your incident data. Incident data means something terrible has happened. Obviously, we don't want something terrible to happen to us, which might then compromise your incident data. So security is obviously top of mind for us, and we care quite a lot about this. In infrastructure, that obviously means doing things the right way. So it means taking advantage of the best practices and the tools that you have in cloud and making sure that you're not making any stupid mistakes. And quite frankly, that if someone follows the golden path to do a thing, so they're deploying that front-end app with the framework that you put in place, it's going to be secure by default, because if they're inventing it from whole cloth each time, it probably won't be. So yeah, that's us. I then kind of went from these principles to what the table stakes are for me when I'm coming in going, I'm going to be managing some of this infrastructure for a very long time. What's the stuff I really care about, making sure that I'm in a good place when we start scaling? And I think I kind of went through them and went, for me, one of the first things that you need to do is have a really good understanding of, for you as a company, what do you mean when you say this is an application? So like, what infrastructure normally comes with an application? What are the selection of infrastructure that you normally use? And what does an environment mean? These are fairly abstract concepts that I think you really benefit from if you can kind of harden the terminology and get people really on board for them. The next thing I wanted to do was make sure that we use infrastructure as code for anything that would eventually become production. I mean, I've spoken about startup priorities and time already. I can tell you right now, if you hand provision something and it's basically working, you're going to really struggle finding the time to go back and backfill that into infrastructure as code. It's just not going to happen. And I will tell you from experience, that stuff has a surprisingly long technical debt shelf life. Cool. And then the third one for me, which I think is interesting because if you nail the first two, you kind of get for free, is that I felt like every developer who was working on our product should have their own environment so that they can test things and experiment. And as a result of having your own environment where you can play, you get a lot more familiar with the infrastructure, which allows people to own it a lot more effectively. And now we have an on-call rotor across all of our engineering team here. We don't have an SRE team as such at the moment. And I think us being able to do this was one of the reasons that we're in that situation right now. Cool. They're the table stakes. So what do we mean by like finding a model for an application environment? So when I first stand up, this was kind of what we had. Also, I apologize, this is a lot more technical than the other talks, and we put it at the end, so just stick with me. So this is what I had when I first stand up. We have like a web and a worker and a cron of our application over on the left-hand side. And this software uses some GCP resources over here, so PubSub and GCS. They also use a Heroku Postgres and a Heroku Memcache because when I stand up, and actually still now, maybe not forever, but at the moment, we're still running our stuff primarily on Heroku. So I think it's always useful to try and add a bit more structure to that because that's kind of a very bitty component level diagram that doesn't tell you much about how you should be thinking if you're working in the app. So this is kind of where you might arrive at when you start thinking a bit more about what this application is, where you have kind of your Go monolith over on the left-hand side, which is powering all of those two things. You've kind of got your Google Cloud Platform estate over here and Heroku, and within them the components that are powering this. So when I'm talking about what is an application and an environment, I think there's some questions that everyone should try and ask of themselves to try and figure out what the answer is for their company. So the first one is, what environments of this application do we actually need? So for us, that meant we obviously need a production environment, because otherwise, not really a startup at that point, right? We need a staging environment too, because we need a mirror of a production environment that we like to deploy changes to, where the infrastructure is exactly the same as production, so we can see if we're going to screw something up before we actually do. And then we also want our developer environments, going back to those table stakes. So we want the ability to be able to stand out developer environments and know what that means when it comes to something like, what do we do about Heroku dependencies? What do they look like? What do we do about GCP? That sort of thing. The next thing is, will the environment share resources? This is like pretty key when you're talking about cloud security and how you're provisioning stuff. Are you going to share resources? The answer that we have for ours is like never. Every environment of this application is going to be very separate, which is going to necessitate some work on our side to make sure that we can print these environments very separately from one another. So that's a key tenet to have it. And then, like, what would an ideal dev environment look like? So I kind of pointed at this. I think if you kind of think about the Heroku stuff down at the bottom, the Postgres and the Memcache, and think about a developer working locally, there's no reason that a developer can't boot Memcache and Postgres themselves in a Docker Compose setup, so we don't really need to worry about that. If anyone has worked with the PubSub emulator, I'm sorry. You don't want to be developing locally against the PubSub emulator. It just freezes for no reason, and your laptop might actually melt. So for us, the ideal dev environment would actually be as close to using production Google infrastructure as possible, if not using production Google infrastructure. But of course, that means we'll need to create separate versions of Google infrastructure for each developer, which we're going to get to later. And then on the left, the Go monolith is fine, right? We want to have to run processes locally. That's not an issue. So yeah, having answered those questions for ourselves, I think we can get some decisions about how we might want to structure our infrastructure and incident.io such that this will work for everything that we've kind of laid out. And Google will sell a project to you as if it's your own little mini data center. So everything that you put within it is isolated, or isolated unless you connect it. Also, iron rules and everything like that cascade down from the project. So even if you are using those kind of broad and slightly dangerous predefined roles, it's still only limited to the project. So that keeps your environment separate and allows you to get off the ground really quick. Whenever anything is talking from your application environment to Google services, it should do so under one service account. This is really nice. Your application environment has an identity, and then you control the IAM from there. No messing around with like different service accounts with different parts of the app when they're all in the same process. That's a nice thing. For staging and production, we need the Heroku environment, right? We are running in Heroku, so we're going to have a separate staging, a separate production Heroku environment. But then when it comes to the developer environment, we'll use Docker Compose to simulate the Heroku stuff. But we will actually provision an entirely separate GCP copy of the resources for everyone to use locally. That means someone can go in and like mess around with their PubSub settings and see what it looks like when they're working locally, which I think is really nice. So cool. We've now got like some idea of the requirements or where we want to go. The next thing is how on earth do we get there? Because like, that will require us to write some code. What does that code kind of look like? So using infrastructure as code for everything that will be production was one of the things we laid out to start. How do we do that? Well, we're going to use Terraform, but there's some complexities there. If any of you have tried figuring this out, how actually do you want to run Terraform? You've got to give it some pretty serious permissions. Where are you going to run that? Like, honestly, how are you even going to boot the thing? Because you've got no Terraform because you haven't yet run it. So, like, that's a bit hard. The next thing is you need to like create an environment, right? So, assuming that you can run Terraform, you need to go create kind of the container for your environment, so the Google project, and the thing that will then provision resources into it. And then you actually need to provision the resources for the environment. So these are our problems, and this is how we solve them. So the first one, there's someone in the audience at least who's going to be very happy about this. I think SpaceShift's like head of GTM is here, so cool. We've kind of circumvented some of these issues by using a tool called Spacelift. So Spacelift are a CI/CD tool for Terraform. Their whole like thing is running Terraform in a secure and safe manner and making it scalable for you. So the cool thing for us is we don't actually have to provision any infrastructure ourselves to run Terraform. What we do instead is we create what's called a stack in Spacelift, which is the idea of a Terraform binary coupled with a Terraform project, so lots of code to provision resources from Terraform, and then coupled with some like environment or variables for the Terraform project. So you're saying like merge them all together, and this is a CI pipeline that I can use to plan my Terraform code and then apply it. So we're going to create a super admin stack, which we're going to confusingly call Spacelift stacks. The next thing that we're going to do is Spacelift will provision a Google service account for that stack, and then whenever the stack runs, they'll inject the credentials using short-lived like OIDC tokens into the environment. So you never touch any keys at all. You just then take that service account, and this is the only bootstrapping thing that you actually do when you're doing it by hand rather than using code, which is you then take that service account, go into your GCP account level IAM, and go, cool, this guy, he can do everything. But that is the only place that we're going to provide the super admin permissions, which is really nice. The last thing that you do before you're kind of all set with how you're going to run Terraform is you do something really weird, which is you import the Spacelift stack into the Spacelift stacks project itself. So Spacelift have a Terraform provider, so you can manage all your Spacelift stacks in Terraform. So you kind of like fix the loop on the bootstrapping stage, and now you have there's no infrastructure that you own now that isn't managed in Terraform, which is really quite neat and nice. Kind of looks like that. You'll note down there that it's got like an administrative flag. That means this stack is going to be able to provision and control other stacks, which is going to be super important because, spoiler alert, we're going to create some more. That's what it looks like in Spacelift, and then we have this diagram, which you're going to see several times as we kind of build it up, where we have the Spacelift stack, which is like the box on the left, and then within the box, all the stuff that it provisions, which, as I said, confusingly, is itself. Probably should have left that out. Cool. So we solved the running Terraform by using Spacelift, which is great. The next thing that we need to do is create an environment. So if you remember back before, consistency is really important to us, as is simplicity. So we want this to be super, super easy for you to do. So what we did was we created a Terraform module. So it kind of looks like this. This Terraform module would create an entirely separate staging and production environment for our primary application. Now the cool thing about this is that the module is doing a bit of heavy lifting for you. So the first thing that the module is doing is it's creating a separate spacelift stack. Remember, these are the CI/CD pipelines. So I'm going to get like incident IO staging and incident IO production, all in a spacelift ready to deploy all of my stuff into it. It's going to create a GCP project because if you go back to how we model applications and environments, each environment gets its own separate GCP project, so its own kind of like mini data center within which you can do all the terrible things it wants without affecting anything else. Finally, we're going to create like an admin service account, which is literally the service account that we will ask the spacelift stack to run with. Now, this is then able to do things inside of the project that we just created, like create a sub VM or provision sub resources, whatever you want to do. So you kind of got yourself all set up, and we've kind of completed the thing on the left here, where our spacelift stack, so the super unit, the super admin stack, is now managing the stack that will then manage all the environments. Cool. If you follow so far, the next thing is kind of easy, which is we now have to provision our resources. So that becomes very easy given what we've just done, because we've got our CI pipeline all set up for staging and production, and it's pointed at the source code, which is projects and incident.io. So it's saying, like, I want to deploy this Terraform code into an environment. The next thing that you do is you create inside of your projects incident.io, where you can see all the Terraform files that are defining our pub stack drivers, storage, whatever. You say for staging, I'd like stuff to look like this. For production, I'd like stuff to look like this. So the key thing, if you've used Terraform, there's always this argument about whether or not you use modules or workspaces or whatever you do. The stuff that's really nice about this is that because all we're doing is using variables to parameterize how staging and production are different, there's no falling out of sync with one another. Now I know this is mostly a security crowd, so I'm not going to sell you on the development benefits, but I am going to sell you on the fact that now you only need to audit one thing, and that should be quite nice, I think. Cool. So we've got like our spacelift stacks all set up, we've got staging and production there, and we've kind of completed this diagram where we have like the super admin thing over on the left that manages itself and a load of other like global account configuration. And then you have many for each one of your different environments over here. You have all of the different pipelines that you've got set up and all the different copies of the resources that you've got. Bearing in mind that, of course, this is a totally different infrastructure for each environment and all entirely separate copies of all the cloud resources within them. Cool. So great, ticked everything off that list. But we still have one more table state thing that we wanted to go through. So at the start, said every developer should get their own environment, and that's something we care about quite a lot. But I also said that if you achieve the first two things, the next should be quite easy, which is that we already have a way to model applications and environments. So we know how to kind of declare another environment, and we know what that environment will look like because we have a think about it at the start. We know like local dev environments will be simulating or running stuff in Docker Compose, for example. And then we had a infrastructural and Terraform way to quickly deploy a different version of the application or a different instance as its own separate environment. So all this actually becomes is this. You just go back into the module and you go, hi, I'm Lawrence, I would like a dev Lawrence environment, and it will create me my own separate copy. And this is actually part of our, we're a fairly early stage startup, so you don't normally have these things. But we do have something that I wrote when I first turned up, which is like a tutorial, which is how you onboard yourself onto the app. And all of our engineers so far have gone through and followed this and been able to add their own environment and get set up with an entirely separate copy of the infrastructure with really minimal effort on our side for the investment that we put in. So yeah, that's like all the table stakes. I'd like to then, having considered how we've gone through this and kind of solve the problem of how we'll deploy application environments, consider like, is this right according to our qualities of right? So is it simple, consistent, and secure? Well, firstly, we've got 3 lines of code for a new environment. I think that's pretty simple. I'm pretty happy with that. We've also had, as I pointed out, the fact that these environments can't really drift that far from one another, which when you're managing an infrastructure estate is pretty important. So yeah, simple is there definitely. All of your applications are deployed in the same way. So obviously I've spoken about our core application, which is our dashboard, our web receiver, like all the stuff that powers that incident response app. But we have other infrastructure that we want to deploy. So we've got things like a Squid web proxy that we use when speaking with issue trackers, because apparently Jira only authenticates using IP whitelisting, you thought. And those things are deployed in exactly the same way as we deploy our other app, and it has its own GCP environment, and it has its own spacelift stack, and everything is kind of processed through exactly the same pattern, which means we get all the benefits of setting things up with spacelift, and like if anyone comes in, and they've worked on our core app, they now know how to debug the stuff with all the other things that we've deployed. The next thing is it works with GCP IAM and actually just GCP best practices really to achieve principle of least privilege. So we have everything separate, nothing is shared, and all of your IAM privileges are scoped to the project, which is just by default really nice. It just avoids a lot of your security issues from the get-go. We then have only one pipeline that has super admin. Now, I've worked on stuff like this before. That's not often the case. If you've not figured out a really nice way to hand off and downgrade your administrative abilities between your CI pipelines, then you can quite often get one big CI pipeline that can do all the things in the account, and that becomes really quite hard to manage or hard to reason about when you're trying to think who can do what and how can we do it safely. So we can actually just lock down that pipeline and have people go through a proper human manual review and approval process before they do anything to it, which is kind of reassurance on our side that everything is going okay. The other thing is, because we're using SpaceLift, they're all keyless. So I hate personally downloading keys and moving them between machines. I think everyone here can agree with that. That sucks. There's no key that has to move around at any point here, which is absolutely lovely. It also means if we ever have a compromise or someone lifts the keys, they're all short-lived. There's a window of maybe 30 minutes of access that will happen. We'll be very upset about that, but we can do other things to try and limit it. It's worked okay so far. We're only a year and a half in at this point, but you can see we've got a good, 18 developers or so who've managed to onboard themselves onto this, and a couple of other different apps. Like we're representing our data pipeline, for example, in exactly the same way as we do our application that we deploy that powers our actual product. That's it. That's how we build stuff here. I'm aware that I've actually catfished people with the talk description, and I said that I was going to talk about how we're using Google Secret Manager and locking things down with security primitives, which I was, and then I realized I'd hit the 20-minute time cap. So if you do have questions about that, either message me, and I'd be happy to share how we layered that on top of this stuff and why it was easy because of the foundations that we've put in place. But also, if you're someone in a similar position, thinking about, I'm either starting using cloud at my company for the first time, or maybe you've just joined a startup and you don't have a clue what you want to do and how it will work. I've actually taken the non-business specific parts of our setup and put it in an example repo, which is linked there, so you can kind of go in and see exactly how the Terraform operates with each other. And if you pick that up and ran with that for SpaceLift, then you'll at least survive until 55 people, I think.